Good morning, students. Today we are going to start your 13th unit of crash course, Electromagnetic Induction. A small unit, important unit and very interesting unit. What is all in this unit? Oersted discovered that current produces magnetic field. After that, so many scientists thought that if current can produce magnetic field, from magnetic field, how to produce current? After 11 years continuous work, Faraday got some results which are known as Faraday's law of electromagnetic induction. First law was this, कि if there is a change in magnetic flux linked with a closed circuit, up to the time change in flux is there, you will find one EMF in the coil. Without battery, you will find one EMF. This EMF is known as induced EMF. In second law, he explained about the strength of the EMF. The strength of EMF is directly proportional to rate of change of magnetic flux. We know that what are flux? If a magnetic field on this page is from left to right, and we put one coil in this magnetic field, it is the direction of magnetic field, it is the direction of coil, means its area. We know that flux related to coil is B dot A. In previous units, I told you that the unit of flux is Weber, SI unit is Weber and CGS unit is Maxwell. 1 Weber means 10 to the power 8 Maxwell. And Weber per meter square is the unit of magnetic field. Weber per meter square means Tesla. Maxwell per centimeter square is CGS unit. It means Gauss. And in 1 Tesla, there are 10 to the power 4 Gauss. B dot A means phi depends upon 3 factors: area in which we place the coil, magnetic field, and angle. If there are n turns in a coil, flux linked with each coil is this, so total flux will become n times this. Suppose theta is continuously changing. It means flux related to coil is changing. According to Faraday, there should be EMF and it should be equal to rate of change of magnetic flux. Suppose your coil is rotating with an angular speed omega. It means in each second, angle moved by coil is omega. So in t second, if it moved by theta angle, theta should be omega into t. Means we can write flux related to coil in this case should be NBA. cos omega t. So according to Faraday, rate of change of magnetic flux means d phi by dt should be, differentiate both sides with respect to t, and b and a are constants. So write as it is. But differentiation of cos omega t is minus omega sin omega t. This. What Faraday explained, that rate of change of magnetic flux is equal to induced EMF. In first law, Faraday gave the reason for this induced EMF. In second law, he explained the strength of induced EMF. After that, one more scientist, Lange, he explained about the direction of this induced EMF. He gave the direction of induced EMF, कि direction should be such that it can oppose the cause which is producing it. Actually, it was the law of conservation of energy. It means what energy you spent to change the magnetic flux, only that will appear in the coil in the form of electrical energy. So he put minus sign. It is according to Lange's law. कि induced EMF will oppose the change of the flux related to coil. So now we can write this d phi by dt minus E. Minus omega NBA sin omega t. E means omega, NBA sin omega t. One important expression, you will get so many numericals on this. Now what is sin omega t? It was the angle moved by the coil in t second. Since theta is changing with time, it means this induced EMF is not constant. It will change with time. Since omega and B and A are constants, it means E will maximize and minimize according to sin theta. So if you want to plot the graph of E with time, it should be like sin theta. If sin theta is 0, it will be 0. If sin theta is maximum, it will be maximum. So it is one complete cycle of E. It means when theta was 0, E was 0. When theta was 0, E was 0. When theta was 90 degree, E was maximum. Again at 180 degree, it becomes 0. At 370 degree, it is maximum but in opposite direction. It means after half cycle, it will change its direction. It means it is not direct EMF, it is alternating EMF. after 2 pi again 0, and same cycle will be repeat now. It means what is the frequency of your coil? That should be frequency of this induced EMF. If coil is completing 50 cycles in 1 second, EMF will also complete 50 cycles in 1 second. So frequency of induced EMF will match with the frequency of rotating coil. Getting my point? Now, the maximum value in positive direction is at pi by 2. When we will choose E theta pi by 2, E will be maximize. Maximize value is known as amplitude of EMF, maximum value of induced EMF. So what we will get for E naught? Omega N B A. If we put the value of E naught in this expression, what we will get? We will get E is equals to E0 sin omega t. But we know that if resistance of circuit is R, E upon R is current, dividing both sides by the resistance of the circuit, what we are getting? This. Since this current is related to maximum value of E naught, it should be the maximum value of current. So same expression we will get for current. I is equals to I0 sin omega t. It is induced current. So frequency of induced current, again it should be same as the frequency of rotating coil. So remember this, very important results these are. What we say in a general, E is equals to minus change in flux upon time in which this change occurs. But E is equals to I into R, means I is equals into R is equals to minus delta phi by t. If in t second, due to this induced current, phi charge is induced, we can write I charge upon time, rate of change of flow of charge. So now we are getting one expression for induced charge, means induced charge will depend only upon two things: change in flux upon resistance of the circuit. So these relations are very important in your competitive exam. They can ask these relations or problem based on these relations. Now we will discuss some conceptual problems which they can ask in NEET exam. Suppose I drop a magnet and I hold one ring whose plane is horizontal, and we suppose that it will pass through this hole, this ring. They can ask you, is there any induced current in this coil, in this ring? And if yes, what is the direction of that current? Number 2, will this current affect the acceleration of this magnet which is coming vertically downward? Means what we did? It is a ring. We drop a magnet like this, it will cross the ring. They can make 4 options. Acceleration of this magnet. Initially it was less than g. When it crossed the loop or ring, then it was greater than g. Or it will move with only acceleration g. There is no change in acceleration of magnet. Or initially it was greater than g. After crossing the ring, it was less than g. So what will happen when this magnet will cross the ring? See, in a ring, induced current will generate. Why? Since magnet is coming closer to the ring, so flux related with ring are continuously changing. It is increasing. What is the cause of rate of change of flux? Motion of magnet. So this current will try to stop the magnet. To stop the magnet, the upper portion of ring will become north pole. We know that if in a ring current is flowing in anti-clockwise direction, it will become north pole. So if you see from upper side, you will find that current is flowing in anti-clockwise direction. So it will become north pole. Now this north pole will start repelling this magnet. Means putting one force in opposite to the gravity. So this magnet now will come with acceleration less than g. What will happen when it will cross the ring? Now, what is happening here? According to this figure, now magnet is moving away from the ring. Means flux related with ring now are decreasing. Again it is changing. Again there should be one induced current, induced EMF, which will oppose again the motion of magnet. Since south pole is moving away from magnet, to stop it, now downside of the ring will become north pole, so that it can attract the magnet, it can reduce the motion of magnet. So again it will fall with acceleration which should be less than g. Getting my point? Sometimes what they are doing, they are making coil but not complete coil. They will put some gap and then they will ask, if magnet is coming, what should be the acceleration of magnet? See what Faraday told us. If flux related to a closed circuit is changing, then there should be a induced EMF. But in this case, since circuit is break, so no induced current you will find here. So it means now it will fall with acceleration equal to g. In this case, if the ring is broken, so be alert what question they are framing. See, be observant what is the figure. So this was problem related to Lenz's law. And what is Lenz's law or Faraday's law? Actually they are law of conservation of energy. Ki energy cannot be produced by itself. Only it can transfer from one form to another form. Getting my point? Next point is this. if a conductor is moving in a magnetic field, one induced EMF will generate in that conductor. Induced EMF, not induced current, because circuit is not completed. So one induced EMF will generated in that EMF. What should be the magnitude of that? What should be the magnitude of that EMF? We will discuss about that. Means what we are discussing? A conductor moving in magnetic field. Suppose I have a metallic U-type structure. This is. And plane of this structure is the plane of paper. And magnetic field is everywhere on the paper. I am putting cross means it is inward magnetic field, means lines of force are going inside the paper. Dot means outward, cross means inward. Now, everywhere I am putting less cross, but cross is very near to each other and it is everywhere. It is uniform, means magnetic lines of force are equidistant. Now, I have one conductor, this. Of length L. A conductor of length L. Which is moving with a velocity v. Definitely it will cut the magnetic flux at 90 degree. This is a conductor AB. After a small interval of time t, suppose it is at this position. It moved by a small distance dx, now it is at this place. The distance moved by conductor in t second, now conductor is at this place. At the position A dash, B dash, after moving a small distance dx. What happened to this? See, initially it was a closed coil ABCD. Some flux were passing through this portion. But when I move the conductor, flux is continuously increasing. What amount of flux is increased in this time in which this conductor moved a distance dx? Flux related to this area increased now. If flux density is B, it means in unit area, number of flux is B. So, what is this area? This area is L into dx. Flux related to this area, it should be area into flux density. it is change in flux d phi. This change occurred in dt second. So rate of change of flux is d phi by dt, dividing both sides by dt. What we are getting? It is induced EMF, magnitude of induced EMF, rate of change of magnetic flux. But dx upon dt is velocity of this conductor. So what we got? We got E is equals to BLV. We got one expression. So what we are getting result? If L length conductor is moving in a magnetic field B, cutting the flux at perpendicularly with velocity V, an induced EMF will generate in that conductor and its magnitude will be BLV. Its magnitude will be BLV. Getting my point? So not a very tough, but in exam what they are doing, they are framing problem differently. Which type of problem they can frame? Suppose a magnetic field is there. It is a magnetic field. Again I am making inward magnetic field. Everywhere lines of force are there. On this paper, everywhere lines of force are there. I have one conductor. Which placed like this. Whose length is L? Length is L. It is moving about an axis passing through A, perpendicular to the plane of paper. It is rotating about one end like this in a circle. It is moving in a circle, cutting magnetic lines of force perpendicularly, and it is moving with constant angular velocity omega. What induced EMF will generate in this case? How to calculate? Formula is this only. Now, rod is moving with constant angular velocity. You can observe that each portion of rod is not moving with constant linear speed. If velocity at this end is v, velocity at this end is 0. So we can take average velocity 0 plus v by 2 means induced EMF which will generate in this, it will be B L v by 2. But what is v? The linear velocity of this end. We know that v should be equal to omega into r, but in this case r means length of rod. So we can write v omega into L. So what we will get? Half b omega L into L square. So you will get half b omega L square. This amount of induced EMF will generate in this rod if it is moving in a magnetic field like this. One end is fixed. So this type of numericals they can ask in your NEET examination. Now we will discuss little bit about eddy currents. What are eddy currents? If in place of a conductor, a linear conductor or a rod, a solid sphere or disk is moving in a magnetic field, you will see that induced EMF will generate on the surface of that solid figure, which is in nature like eddy currents. That's why it is known as eddy currents. Eddy currents means when flood is in river, in water you will see these eddy currents. So due to that we are saying eddy currents. So this phenomena is very useful in daily life. What we are using, if you need a lots of heat energy, we are putting a solid conducting surface of high resistance in a moving magnetic field. Since this surface is in a moving magnetic field, induced EMF will generate on the surface. And you know that electricity can produce heating effect, Joule's heating effect. So you will get a huge amount of heat. So in furnace, we are using this concept. Even in brakes in trains, we are using this concept. What we are doing? We are attaching a drum with each axle of wheels. When we want to stop the train, we will produce a magnetic field there. Now the drum is rotating in a magnetic field. So at the surface of drum, eddy currents will produced, and they will try to oppose the reason, means try to oppose the motion of that cylinder, and they will stop the train. So in electric brakes we are using this concept. So these are about eddy currents. Since a transformer is based on induced currents concept, so there are also eddy currents. When we are making the transformer, we are using metallic frames on which we are winding the coils. This concept is again there, but there eddy currents are cause of the loss of our energy. To reduce this, what we are doing there, we are laminating the cores. So this was all about eddy currents. Now we will discuss little bit about self-inductance and mutual inductance. What is that concept of self-inductance and mutual inductance? See, when we have a coil attached with a electric circuit, it is a rheostat, variable resistance. We can change the resistance. In this way we can change the current. If you on the switch, current will start flowing through the coil. We know that current produces magnetic field. So some lines of force are passing through this coil. If you make current stronger, magnetic field will be strong. More lines of force will be there. It means the number of lines of force are related to this coil are proportional to the current passing through this. If you will change the current, if you will change the strength of current, the strength of magnetic field will also change. If there is a change in magnetic field related to coil, you will find one induced EMF there. Since its nature is to oppose the cause, so if you are decreasing the current, it will support your battery. If you are increasing the current, it will oppose your main battery. But by changing a current flowing through a coil, we are getting one more EMF in that coil. This phenomena is known as self-induction. So what we are observing there, that flux related to coil is directly proportional to I. When you remove this proportionality sign, you will get one constant known as coefficient of self-inductance. Coefficient of self-inductance. But Faraday told us that induced EMF in a coil is equals to d phi by dt minus d phi by dt. But if there are n turns, in each turn you will find this induced EMF. So total induced EMF in that case should be minus n d phi by dt. So we can write E is equals to, n is constant, you can take inside the sign of differentiation, minus d upon dt of n phi. But we saw that n phi is Li, so we can write it minus d upon dt of Li. L is again constant, take outside the sign of differentiation. So now one new definition for induced EMF is there. Induced EMF in this coil is directly proportional to rate of change of current in the coil. And we can define L with this relation. If rate of change of current in a coil is 1 unit, we can define L. If rate of change of current in a coil is 1 unit, EMF induced in coil should be equal to coefficient of self-inductance. Means L become E if di by dt is 1. Unit of this L is Henry. Unit of this L is Henry, denoted by H. And CGS unit in whole current electricity, if you put two letters A, B in front of SI unit, you get CGS unit. Ab volt means CGS unit of volt in current electricity. Ab Henry, CGS unit of inductance, and 1 Henry is equals to 10 to the power 9 ab Henry. And remember, 1 volt is equals to 10 to the power 8 ab volt. So getting my point?